Help me video. Question 1. We've got some lengths, surface areas and volumes for 3 different organisms. Calculate the surface area to volume ratio. If we are calculating ratios, well, we're having the volume as 1, because it's going to be something to 1. And so how do we turn a number into 1? We divide it by itself. And so we do the same to the other number as well. So we divide it by, so we divide the volume by the volume, and we need to do that to the surface area as well. So divide the surface area by the volume, and you just put that into your calculator, those 2 numbers if you can. Give one advantage and one disadvantage of the tracheal system. This is not a general question about gas exchange surfaces in different organisms. It says the tracheal system, so it's got to be specific to insects. So use your notes to find one good thing about the tracheal system, and then this disadvantage is about generally how this affects, one negative thing about how this affects insects. Part B, use the table to explain why the amoeba doesn't need a specialised surface. So you can talk about this surface area to volume ratio and the length. In fact, you can talk about the surface areas and volume separately as well for points, and really explain how the amoeba does get everything that it needs. So what is it about an amoeba that means it can rely on one method alone? Part C, how mammals maintain the gradient. So some people have struggled to answer this, and it's because they've not answered that highlighted bit, which is maintain the gradient. They've told us why you need a gradient or so on. But how do they maintain this? You need to talk about, so if the mammalian gas exchange surface is, imagine alveoli, so you've got air in there, and that's a thin wall of squamous epithelial cells. And then you've got close by, you might have a capillary. So what do you need to do to the air to maintain that gradient, and what do you need to do in the blood to maintain that gradient? So 2 separate points there. Suggest why cellular demand for oxygen is lower in a fish compared to a dog of the same size. So a dog-sized fish, I want to meet that. And you need to, it's really about a lot of people have suggested this, fish is less active than a dog, but we need to do more than that. So think about the place where the fish lives. So you've got fish are underwater, where the dog is having to scamper around on land. So think about the relative ease of movement as a clue for that. Then part E, we've got some information here which is useful about when mammals and birds evolved, and then a difference in the shape. So this is new to you, you don't recognise this, but you've got to think, what information do I know? And that's the information that they're going to want. So how do you account for the difference in size and structure of the blood cells? So we want in here you to talk about mammalian blood cells. So we want you to make 4 points. It says they are biconcave, so it's told you that. It's told you that they do not have a nucleus and are much smaller. So they are biconcave. They do not have a nucleus, are much smaller. So we don't want you to guess about what birds are or give the reverse argument for birds. We want you to go, they're biconcave. Here's how it helps. They do not have a nucleus. This is how it helps. They're much smaller. This is how it helps. And then you've got 3 things there, and then you've got to pick up just another one somewhere. Good luck.